Hello students, today we are going to discuss an important topic and that is interesting also, that we call as functions. Once we write softwares or programs that are large enough with thousands of lines of codes, it will be very difficult to understand such programs, and it will be difficult to debug such programs because examining thousands of lines of code for an error is a tedious task. Again, it will be very difficult to understand this code, and it won't be evident that which part of the program is performing a specific task. In order to make the program structure simple, the concept of function was designed. That is, in which we divide our program into different, say, sub-programs, and each sub-program performs a specific task. It is something like division of the labor and giving a specific task to every piece of code, and that piece of code or that block of code is efficient enough to perform that task. So with the concept of functions, we actually divide our program into different sub programs or functions. Each function is an independent or self contained block of code that can be called again and again. Now, calling again and again is a new term for you, but as I proceed with the lecture, it will be clear. Right now, you remember function is a independent or self-contained block of code that can be called again and again. By calling again and again, I can give a bit of explanation. It means using the block of code again and again. So calling is using. I hope it is clear now that in order that our C programs are not containing thousands of lines of code and the program structure is not complex, we divide our program into different sub-programs or functions. Each function is called a module. For example, if we have a program in which I am adding two numbers, then I am calculating at some other place roots of a quadratic equation, then at some other place I am sorting group of numbers. If I write this program as a single block of code, it will be very difficult to understand and debug such program. Therefore, we divide the program into different pieces or functions or parts, and each part does a specific function. So that is why we need functions. We need functions for dividing the program into different modules, and each module performs a specific task, and that module has a well defined task. That module is an independent block of code. That means it its execution is independent. Enhancing the understandability of the program can be also achieved by dividing the programs into different functions. Now, once we have divided the program into different parts or functions, so each part can be examined separately if the error has occurred. So debugging will be easier. Now again, since each part can be used again and again, that means suppose we write a subprogram to sort 10 numbers, that can be used any times whenever we want to use that part. That is, we can call that part. Using a block of code is called calling a block of code. Now, since that part can be used again and again, the technical term for that is reusability of the code. Now, once we write a part or a function with a specific, what you call, we give it a specific implementation for solving a particular problem, we can form a library of functions. In the library, we can have large number of functions, each function performing a independent task, and those functions can be called again and again. Once we implement this concept, it will be clear. Next, what are the important things for function design? One is, whenever we want to give a particular function to a block of code, we should know what are the inputs, what are the outputs, and what is the processing that is to be performed by that block of code or by that function. Now I will use function now onwards. Now suppose I want to add two numbers, that is, I want to write a function to add two numbers. I will identify my two inputs, that is, I should give that function, or I should supply that function with two numbers. That function should add the two numbers, that means it should have a programming logic for addition, then it should give me the answer. So if I write a block of code or a function that performs the addition of two numbers, the important requirements for that block of code are the two numbers, and then that block of code should add those two numbers, and then that block of code should give me the result. So this is what I mean by function, giving the specific task, that is addition, to a block of code. Suppose in this example, the task I have assigned is addition of two numbers. Now we have a next example. Suppose I will write a block of code or a function that finds the volume of a cuboid. As all of us know, volume of a cuboid can be computed if we know three values, that is the length of the cuboid, that is the length of its side, and the breadth of its side, and the height. Once we know the length, breadth, and height, we can know the volume of cuboid. So the inputs to this function are length, breadth, and height, and this function should compute the volume by multiplying length, breadth, and height, and it should generate an output, that is the volume of a cuboid. Now why are we identifying inputs and outputs? Because that way we will know the number of variables that will be required by the function to store the data and to store the results. Now the third example is, if I want to write a block of a code or a function to find the largest of two numbers. To find the largest of two numbers, I need two numbers. These will be inputs to that block of code. Then that block of code should perform the processing, that is the comparison of these two numbers, and then it should give me the message which number is largest. In this case, we need not to compute the result. Therefore, we need a message only. So this block of code accepts two numbers, that is this function accepts two numbers as input and compares the two numbers and generates the output. If I give it some other two numbers, it should do the same. So the same block of code can be used again and again with different inputs. Now next, if I write a function that displays a message hello, such function will not have any inputs. It does not do any processing, no calculations are done, and it generates the output not in the form of result, but it displays a message on the screen. So no output variables are required. I have given these three examples for different functions. The first function was to add the two numbers. I have identified the inputs and the outputs, and I have identified the processing. In this example, we need two numbers as a data that should be supplied to the function, and then the function will perform the addition of two numbers, then it will generate the result. In the second example, I gave that I need to write a function or a module that will find the volume of a cuboid. That means I need to write the set of lines or set of lines of code or lines of code that will find the volume of a cuboid. For those lines of code, I need to give three inputs, that is three data items, length, breadth and height, and that block of code or that function should multiply these three values and generate the result and give me that result. Now the third example which I discussed was function to find the largest of two numbers. In this example, again I need two numbers. The function should have a logic to determine which number is the largest, and then it should give the message, and in this case message is simply the output that will come on the screen. No results are actually, no outputs are actually generated in the form of numbers, right? Like in the example 2, we generated the output called volume, and in the example 1 we generated an output called sum of two numbers, but here we don't generate any number in the example 3. So we say this example does not have an output, it simply gives a message. Now in the example 4, this function displays a message hello. So it does not have any numbers as input, it does not generate as any numbers as output, it simply displays a message on a screen. That message, the contents of that message are hello. These four examples are very important to explain the concept of functions. Now, by now we have understood a function is an independent block of code or a piece of code that can be used again and again. Again, this function or that block of code is given a specific task and it performs that specific task. It has got inputs and it generates outputs. But we have seen four possibilities. There are functions that may have inputs and may not have outputs, like the message function. Then there may be a function which has got both inputs and outputs, like the sum function and a volume function. Then we may have a function which has the inputs but has no outputs, like the comparison function. Again, functions are independent block of code or set of statements that can do a specific task, and these functions can be made to do those tasks again and again once we have written their programming logic, or once we have written their statements. They can be used again and again, or they can be called again and again. Now, actually, the conceptual, what you call, understanding of the functions comes in a better way through mathematics, because in mathematics you might have learned functions right from the preliminary classes. Now, I won't be going into details of it because it is simply fundamental concept, and every student has studied it once he comes to this level of the studies, that is to the level of programming. Now, suppose we have a function f of x of y. This is how we write a function in maths. Okay, f x comma y, where f is a function, name of the function. Then we can have a name of function as g also, or any small letter that you have seen in mathematics. This is function in two variables x and y, and g is a function in two variables y and z. Now, once I write this function, then I write the computation which I have to do. I write f is a function of x and y, where it should be computed as x plus y. Once the function is written like this, I will call the first part of this, that is LHS of this side, as function declarator. So what do you give in the function declarator? We give the name of the function, that is f or g. Then we give the variables, that is f is a function in two variables, x and y. And usually we give the domain of x and y, that is the type of values that x and y is given. Suppose we say x and y are whole numbers. That means we can only give the value of x and y as whole numbers. Now, how do we do the computations? Once we have written a function like this, I told you first part of the function, that is LHS part, I will call it as a declarator, and the RHS part I will call as a body of a function, and the two of them I'll collectively call as definition. So in the function declarator I give the function name and the variables, and in the mathematics it is understood, or it is defined, what is the domain of x and what is the domain of y. That is the type of values that can be given to x and y. Then after that, on the RHS side, we write the computation, how and x and y, how the values of x and y are being, what you call, processed or manipulated, or what are the operations that are being performed on x and y, what is the way these operations are going to be performed. So we say f is a function, name of a function, then we give the variables of a function, then we say we have to add x and y. So my function definition is equal to, I call these two parts collectively as functional definition because I'll be calling them as a function definition in C. The left hand part I call as a function declarator, the right hand part I call it as a body. I hope now it's clear what is a function definition in mathematics. And same thing I'll be using in C. In the function definition I give the name of a function and the variables, and in the function body I give the computation that I have to do. Once I have defined my function, that is given its declarator and its body, I can now use a function. Using a function is called as calling a function in C. That is, I give the actual values of x and y. Now if x is 2 and y is 3, I will compute it as 2 plus 3, that should be 5. Sorry, there's a mistake here. This should be 5. This should be 5. So f of 2 comma 3 should be 2 plus 3, that is 5. Okay. Now 2 and 3 are called as actual arguments or actual parameters. Their copy is taken into x and y, and x and y I will be calling as formal arguments or formal parameters. I hope this is clear. So f of 2 comma 3 I am giving actual parameters. The copy of or these actual parameters are used in place of formal parameters in the body, and then the computation is done, that's addition, and the result will be 5. Okay. Now if I have another function g, I have got the name of the function as g. Now I have got two parameters, that is y and z. They will be my formal parameters or formal arguments. Then I define my function, I give the body of functions as y divided by z. In fact, I can also define the domain of y and z. Then I give the actual values of y and z. I call these as actual parameters or actual arguments. Then I substitute these actual arguments in place of formal arguments, and I get what you call as a result. And this result is called as a return value. In this case, the return value is 2 because 4 divided by 2 is 2. And in this case, the return value is 5. As I told you, there is a mistake. Instead of 8, you should take it 5 because 2 plus 3 is 5. So whatever value is computed, whenever we give the actual arguments, we call it as a return value. So if I say the function returns a value 7, it means after computation on the actual arguments or actual parameters, according to the body, whatever result you get, that result we call it as a return value. You should remember these terms, and using these terms you can easily understand what is the concept of functions in C, because I have tried to form a correlation between these two concepts, and it is like this only. Now if I say function declarator, it means the first line in which I give the name of the function and the variables x and y, and I define the domain. If I say this is what I call domain of the function variables, that is the type of values that x and y is assuming. Then I give the function body, that is after the equality sign, and then I say defining a function. Definition of a function is now function declarator or function, this is also called function header or function declarator, or the first line of the function. Then I write a body, and body plus function declarator is called as a function definition. Now using a function or calling a function means when I give actual values, that is the values that are being used in computations. Here now I am giving the value of x as 2 and value of y as 3. So x and y will be called as formal parameters that are given as they are given in a declarator, and 2 or 3 are called actual parameters. The values of these 2 and 3 are taken in order in which they are given. That is, x will be taking the value 2 and y will be taking the value 3. It's not like this. Y will not take 2, x will not take 3. Why? Because the order in which we have given and the order in which we have given here, that is actual parameters, and the order, the way we have given what you call formal parameters, in the same order it will assume the values, corresponding values. Now the value computed here, that is 5 here, is called a return value, and the value computed here, that is a 2, is called a return value. So once the function is called, it generates a value or called as return value. Again I have been mentioning calling a function is called using a function. Once you use a function, you give the actual parameters. The copies of these actual parameters will be taken by the formal parameters, and those formal parameters will be processed according to the body, and you will get a result, and that result is called as a return value. Again, the return value has a what you call, we define the type of return values that are being generated, that we call the range of a computed value. Now each function has a domain. By domain I mean the type of values that will be taken by x and y, and by range I mean once you give the values of x and y actually, and the type of values that will be computed as result. That type of values are of significance in C. So we'll be writing the same function in a C methodology, that is in the C syntax, and we'll be translating this function into C. This is simply the function to add two numbers, where we have got two numbers x and y, and we have their domain of x and y. We have got name of function as f, and we are adding the two numbers. Whenever you give any two numbers in this function f, you will be adding those two numbers, because the logic is like that. We have written x plus y. Whenever you will be supplying two numbers to the g, it will be dividing the two numbers, that is the first number with the second number. I think domain is clear, range is clear. Domain is the type of values that are assumed by the actual formal parameters or formal arguments, and range is the type of values that are being computed. I hope this is clear. Now we can go into C syntax, and that way you can understand the concept here. Now the syntax of the functions, whenever we create a function or a block of code that can be called or used again and again, you have to first give the return type. Return type I have already told, the type of values that will be computed by the function. Then we have to give function name. This return type depends on the operations that we are performing within the function. Now suppose we are here in this case, if I define x, y and z as two whole numbers, but the result of y and z will be sometimes float also, because, or real numbers, because we are doing the division operations. Because say I say 3 by 2 or 3 divided by 2, both of them are whole numbers, but the answer is 1.5, that is a real number. So range is not necessarily the same as the domain, or the type of values that are computed by the function is not necessarily same as the type of values that same as the type of the variables that are used in the function. So if I, in this case again, if I define the domain as two whole numbers, definitely range will be whole numbers, because once we add two whole numbers, we'll always get a whole number. But once we divide two whole numbers, in this case, I will not necessarily get a whole number. So the range in this case will be whole number, and the range in this case will be real number. That number that is generated by the result, its data type, or the what you call the type of value it is, that is of a great significance in C, that is in writing the functions in C. Again here, this return type will be the type of values that will be generated by the function. That is the type of results that will be produced by the function. That is the type of results. That is the data type of the results. Now then we have got a function name as in C, f of. Then again here we have got variable names, variable 1, variable 2, variable 3. This is the first line of the function. That is the LHS of the function. In math it is like this. That is, we give the name of the function as a single alphabet followed by two short braces. Then we give the name of variables separated by commas. Okay. Now the same thing in C is written in a different fashion. First we give the function name. It may be a single letter or it can be a full name, but the function name will have same rule as variable name. As I have explained variable name in previous classes, you know the rules for naming a variable. Same rules will apply to the function name. That means it cannot contain a space, it should not begin with a digit, and certain special characters are allowed, certain special characters are not allowed, so on and so forth. For that you can refer to my video on variables. Now after that function name, there is a short braces. This is same in mathematics. Then we have got variable name separated by commas. This is again same as we do in mathematics. Again, the variable names can be more than one alphabet, and then but the difference between math and functions is that we have to give the data type of these variables. This is same as the domain of x and y. As I told you, x and y are whole numbers, but it is understood. We don't write domain here in mathematics. We don't write here x such that x is a whole number or y. We simply write f short versus x comma y, and we already know that x and y we have defined at some of the places that they are to be taken as whole numbers. Now this part is, you have got a function name, you have got variable names separated by commas, but difference in C is that before each variable name you have to give the domain or the data type of the variable. Then again, another difference is the type of value that is being computed after the operations. You have to specify that type of value here, that is here. Return type is the type of value that is being computed. That means the range of a function. Range of a function is the type of values that are being computed. That is, the type of values means it can be integers, it can be real numbers, it can be floats, once the operations are being performed on the variables of a function. Now these variables are called as formal variables or formal parameters or formal arguments. These are called formal arguments or formal parameters. We have not used the function, we are defining the function. As I told you, these two lines are the definition of a function. Here in this diagram I am giving the syntax of the function. That is how I define my function. That is the first two lines of this mathematics. That is the left hand part and right hand part. In the left hand part you give the name of a function in mathematics followed by two braces, then variables. What's the difference in the first line, that is the left hand part of the mathematics and the C, is that we give one more additional thing, that is the return type here. That is, if I go back, I give name of the function, then I give two variables x and y. Suppose these are integers. In C I will write here int x and int, after that space, then x, and y, and before that int. And the type of values that will be computed, I know if I add two integers I'll be getting an integer, so I write a return type as int. So this is the difference between the C syntax and mathematics. We give a return type here, then we give a function name here, that is same, but then after that we give the data type of variable followed by variable name. Now is the body of a function. In mathematics we write the body of the function after the equal to sign, but in C we have to write two curly braces, and within that we write the body. Okay, then we write the computation within the body, that is this, and here we have to write a computation within this body, the lines of the code or the statements through which we will be adding the two numbers. Okay, then we have to again mention the variable, because here whatever inputs and outputs are there, they have to be stored in the variables. They have to be stored in the variables. The number of the inputs in the program will determine the number of actual parameters, or formal parameters or formal arguments, and the number of outputs that I have will determine my return statement. Now the type of values that will be computed by the function will be given by the return type. I hope it's clear now. Every function has two parts. What's the first part? That first part is the first line, called as function declarator or function header. Then the second part is the function header. Then we have got another part, that is the return type. Actually we have, the first line has two parts, that is a part, that is the return type, and then we have got a function name, and then we have got argument list or parameter list. So the first line consists of three things, that is the return type, function name, and the formal parameter list or formal argument list, followed by the body of a function. Okay, now function body contains a special statement called as return statement, and return has the following syntax: return space value or variable or expression or function call. Right now we will be using a simple syntax, that is return variable. Return variable. Once I code it in the IDE, it will be clear what I am saying. Now function definition or function implementation consists of two parts. One is the first line, that is the function header or function declarator, and the body of a function that I have already explained. Using a function means now see here, I have defined my function here. This is the function definition, that is the function declarator and the function body. But I have not used it. Using means giving the values to x and y, performing the operations, getting the results. So, but this thing will be done according to the body. See, here we are doing division. Why? Because in the body there is division. Here we are doing addition because in the body there is addition. Okay. Now, using a function is called calling a function. Calling a function, the function will be always called by another function. This will be clear once I show it in ID. The first function that is called is the main, and we don't call that function. That function is called by the operating system. Remember it like that right now. The first function that is being called is the main, and we are not calling it. It is being called by the operating system. Now our program execution, I told you, it is always beginning with the main. Now if you want to define a function first, you have to write its definition, and then you can use it. How we define a function and how we use it. Using a function is called calling a function. A function is called by another function, and the function which calls a function is called a caller or a callee, and the function that is being called or used is called a called function. Okay. Now there are certain topics related to functions. These are call and return mechanism, that is function linkage, scope and extent of the variables, that is visibility and longevity. Then we have recursion and user defined and library functions, then header files, then function templates, function overloading, parameter passing methods, function with variable number of arguments, and function with default arguments. And then we have inline functions. Okay. Once I be going ahead with these concepts and the basic concepts will be clear, I can go with these advanced concepts later on. Okay. Now let us go into the IDE and work out the examples that we have learned today. I'll start with the first example. That will be the easier one. That is how we write a function to print a message. As I told you, main is a function. Okay. The structure of the function is void is the return type of this function, main is the name of the function, then there are two short braces, and then there are two curly braces. Okay. Within these two curly braces we have the body of the function. Any function that we write should be written in this form only. First we give the return type. Say suppose return type is void, and my function which I am using to display message, I will call it as a dis function or display MES message function, display MESSAGE function. This is my function name. First I am giving the return type, then I give the first short bracket, then the second short bracket. Since I don't have arguments in this function, I give it like this, and I write the body of a function. Within this body of a function I will write a print f. Here I'll say hello. Okay, this is the simplest example that I can give you to make you understand how functions work. Simple example. First you give the return type. Return type is a void. Since we are not computing any values here, we are not adding the numbers or we are not dividing, we are not performing any operations within this function, we are simply displaying a message. So return type will be in that case void. Now return type can be any data type of the C, that is user defined data type, or it is a basic or primitive data types, or it's a derived data type. Right now I'll be using only primitive or basic data types, that is int, char, float and double, and as we move on we can see how we use return types and user defined data types and derived data types. Now since this function does not have any numbers on which it is going to do any computations, so it does not have any arguments, and now this function does not compute any value, so its return type is void. Once the function does not compute value, its return type is void. Same is the return type of the main. But we can have a return type here in case the function computes a value. Now, how do we use a function? First, we have defined the function, that is, we have written its declarator and we have written its body. Now, I will call a function. Calling a function is simply giving the name of a function, display message. Since the function does not have any arguments, so I'll put a semicolon here. Now, main is the function which is calling or using a display message function. So there's a rule that one function will call another function. Okay, who will be the first function that's called? That is main. Let us see how it is. I will go into the trace mode and do the stepwise execution. So this is the first function that is being executed, is the main, because it is being highlighted here. Now after that, I am using a display message. Now I jump from the main to the display message. This is the block of code I want to use. Now this block of code, what does it do? It prints a message hello. Now you see the message hello is being printed. Okay, since this function is executed, the control returns to the main, and this function has been executed, and we move out of the main. So using a function is called calling a function. Once we call a function or use a function from any other function, control is transferred to that function. After execution of the function, that is all the statements, once they are being executed for that particular function, the control returns to the caller. Here the main is the calling function or the callee, and display message is the called function. Okay, so who is calling? Main is calling. Whom it is calling? He is calling display message. What does it want display message to do? It wants it to display a message hello. Now let us do it again once more, but I will call the function twice now. I can call the function as many times as I want. That is why I defined the function as an independent block of code that can be called again and again, means use it again and again. Independent block of code that can be used again and again. You can call display message as many times as you want, and each time you call the display message, it will perform the task that you have assigned to it, and once it has performed the task, it will come back to the function, or the control will return back to the function which has called it. Now let us again see it. I told you main is the first function that is being executed. So main is a function, as I told you in the previous classes. I told you to remember at that time. Now we have understood the concept of the functions to some extent, and as I move ahead you will understand it fully. The main, it is calling a function called CLR_SCR. We have not written this function. This function, what it does, it clears the screen. Screen is cleared. Now after that I am calling, main is calling another function, that is display message. If you see from here, this highlighter will move now to the display message. That means control has been transferred to the display message. By transferring of the control to the display message means that its steps will be executed. The first step, that the first statement inside the display message is print hello, and it should print me a message. See here, the message has come, print hello. Now after this, the control should transfer back to the main. It comes back to the main, but to the next statement after this, and next statement happens to be again a display message. That means I am calling this function second time. Now again it will display the message. Again it has displayed the message, that is hello has come twice. So I can call again it control transfers to the main. Since there is no statement after this second display message, so the main, we come to the last statement of the main, and main is terminated. So the program execution begins at the main and the program execution ends at the main. So if we have to call any function, we have to initially call it from the main. There is a rule, any function can call any other function. This is a rule, that any other function can call any other function. But since the execution begins at the main, so the main is the first function who will be calling some other function. Okay, now I hope this is clear. I have told you function is a, now if I wanted to print this message 1000 times, I can call this display message 1000 times instead of writing this print of message. Now imagine the situation where display message does some task that is a what you call a specialized task, and it has got 100 lines of codes, and I don't have to write those 100 lines of codes again and again. I have to simply call this function, give it my task, it will perform the task, and the control will be transferred back. That is why we call a function as a module. And now we have divided our program into two functions, and the main module is the module, or the main function is a function who will be utilizing these functions, and then these functions can also utilize each other wherever they need them. They are what you call wherever they need each other. Now let us write another function to add two numbers. Now this function was the function without arguments and without return types. Now suppose I write a function which adds two numbers. Again, I will write the first line of the function. The first line of the function has a return type. I will write the return type as an integer, because once I add two integers I get an integer. Now I call this function as a sum. Then I give two arguments, that is the int. First I give the data type, then I give the variable name as x, then I give int, and then I give the variable name as suppose y. Now I write the body of this function, that is I write two braces. This is the structure of any function. It has got two things. One is the first part, that is the function header or a declarator. Then it has got a body within two curly braces. Whatever function you write, you have to write this structure. Now once I want to add x and y, but C syntax does not allow me this. I cannot write an expression like this. I have to always assign it to some variable, say answer. Now the answer I am using within this function, that is sum, in the body. I have to declare answer, because I cannot use it without declaring. Whatever statements are there in C, that is input output statements, assignment statements, conditional statements, iterative statements, declarative statements, they can be written in any function. Okay, no problem. Whatever you can write in one function, these statements can be written in the body of any function. That means you can write any programming logic by using these statements within any function. There is no restriction that you can use these statements in main only. You can write these statements in any function. Now right now I am writing the assignment statement within the sum, and I am using another declarative statement. Now one thing you should remember, that if the name of the function is sum, the name of variable cannot be same. So I will call it as a result now, and I will store it here in the result, and then I will return this result. It will be clear now. Now see actually what happens. I am not using or calling a function, because as I told you in mathematics, whenever we use or call a function, we give the actual values. Here we are giving simply defining a function, that is we are giving the first, what you call the first line that was given in methods, that is suppose f of x comma y then is equal to x plus y. This is something that, like that, exactly like that. That is, we give the name of a function, we give the variables of a function, but here in addition we give the data type of those variables. Then in the body we write what you call what we have to do, and but we cannot write the statement like x plus y. We have to write a assignment statement, and we assign our answer to result, and then we return the result. Now data type of the result is int, and I have to assign this data type depending on the type of operation. If the type of operation would have been division, then I would not have returned it into the result. Sorry, I would not have returned it into the result whose type was int. In that case I had to declare result as float, because it will be a real number in that case, so that I can accommodate both integers and real numbers. And then here the return type should be also float. Now let us again see how we call this function. Now main will be calling or using this function. How we call a function? We give the name of the function, then we give the values. Now 2, 3 are the values. Okay. Now once the function returns a value, it will return some value to the main. How do I store that value? I say equal to, say, some variable L. Now this variable L I have declared, should be declared in the main, int L. Okay. Now you can see once I execute it, you can understand what is happening. See, first main will be called, then I am clearing the screen, then sum will be called. Now I'll be watching options, debug, watch, and watch. What is the value of X? Debug, watch, watches, and watch. What is the value of Y? Now this is important. Did I give value 2 and 3 to X and Y? No, there is a mechanism, inbuilt mechanism. Whenever you call the value function with some values, that is actual values, the copy of these actual values will be passed to X and it will be passed to Y. Here is the proof for this. Because X has the value, now X is actually a variable of type int and Y is a variable of type int. Now value of X is to Y because you have given first argument as 2 and then you have given second argument as 3. Like in mathematics, you say f of x comma y is equal to f of x comma y is equal to x plus y. Then you say f of 2 comma 3. Now 2 is the value of x and 3 is the value of y. But here C will do it automatically. It will substitute the value of 2 or pass its copy to x and pass the copy of 3 to the y. Then what happens? Now another variable is being created as a result. I will again watch that. Alt D. Sorry. I will watch my result. Now another variable result has been created and before this statement, after execution of this statement, it is junk. Now after execution of the next one, it becomes 5. So that's right, 2 plus 3 is 5. That is stored in result and this return result is returned here. That is, the function returns a value at a point of call. You simply understand it like this. This sum and bracket of 2 comma 3 followed by short bracket will be replaced with, or this will give me a value called 5 and that 5 will be assigned to the L. So you can see like this, Control Alt W. Now I will see, sorry, Alt D. I will watch the value of L. You see, L is undefined unless I come back to the main. Now L has the value 5. So my sum has done the job. It has added 2 and 3 and it has returned the value that it has computed and I have stored that value in the L. Okay, this is the mechanism of call and return. I hope it's clear now. Here you can see I have a function sum. It does a task of adding the two numbers. Then main is using this sum. It is giving it some values and the sum is performing the addition of these values and the sum is giving the result to the main. And then main means, because I am calling the function within the main's body, that is within its braces, that returned value is assigned to the L. Now I can display L. Suppose printf the result of addition is this is the message. Now once I execute this program, you will see first I am calling, main is calling the sum, control is transferred to the sum, the copy of 2 and 3 goes to x and y, here 2 and 3, then that 2 and 3 is added and the answer is stored in the result. This is the independent block of code. Now again I get the result as 5. That result is returned to the main and that is stored in L, and now I display that result and you say the result of addition is 5. This way you can understand how function is an independent block of code. Now can I use sum again? Now with the different values I have copied this, suppose 5 and 15. Now this block of code will be called first time with the values 2 and 3, and the next time it will be called with 5 and 15. So sum is performing the addition of two numbers. It has a specific task, so it has a specific function. So it is an independent block of code that adds the two numbers, and it does that job. It's a module. It's a module. Now let me see what happens. See, the first time sum is called, control is transferred to the sum, the result is generated, it is 5, it is returned to the main, the result is stored in L, and I am displaying L, and the result of L is 5. Okay, now again I am calling it, but with different values, that is 5 and 15, and the result is generated as 20, and that result is returned to the main, and again I am storing that result in L, then again the result is displayed as 15. I can call this sum as many times as possible. There is no limit to it. So again, main is a calling function. It is calling the sum. It is giving it actual parameters. The copy of the actual parameters goes into the formal parameters. They are being processed according to the statements that are written in the sum. Then the sum value is computed, and that value computed, that is the return value, is given to the main, and that is who is main. Main is the function who is calling, and then that value, return value, is assigned to the L, and we can see the answer. Now I am again calling the sum, but with different values. So sum can be called again and again. I can use the code again and again. That is what I mean by reusability of the code. Now if I write some other function, it's not necessary that now this program has two functions. One is the main and one is the sum. Let us write another function. That will be called as largest of the two numbers. Okay, now what is the syntax for writing the function? Again, one function cannot be defined in the body of another function. This is an independent block of code. It has got to have a first line and then two curly braces, then the statements within these two curly braces. If I write another function, I'll say int, suppose I'll say the return type as void, suppose that is, then I can say name of a function, I call it as a large, and then I give the two numbers, that is int a comma int b. This is the first line of the function. Then after that we have got the two braces, that's body. The first these two are collectively called as definition. I am repeating it again so that you remember. Then I use a if statement to find if a is greater than b. I told you you can write any statement within the function. If a is greater than b, I can give the message here. This if is now within the function, so I have to take care of these braces. If has got two braces and else has got two braces. I have explained this in the conditional statements. Okay, if now I give the first message, if this condition happens to be true, I give the message a is largest, and if this condition fails, I'll say b is largest. Now I have got three independent block of codes here. One is the main, one is the function largest, and one is the function large, and one is the function sum. What does the large do? It is an independent block of code. It can check whether the which number is the largest out of the two numbers that you are giving to it, these inputs, that a and b. But does it compute any value? No, it does not compute. It gives a message. So return type is void. But in this first example, it computes a value, so the return type is int, and the return type of int should match with the return type of the sum, and it should match with the return type of the variable in which I am assigning. This is important. Okay, now I will be using this function. How I use this function? I will call now, I will not be assigning a value here. Why? Because I am simply, I can call sum anytime. I can call what you call large anytime I want. The function can be used or called as many times as you want. But who will be calling again? Main, because who will be calling the main? Operating system. Now main can call other functions, because if main won't call, it will be never called. Okay. Now I call the large function. I give the two values to it. Now let us first. Now first I'm calling the sum. Who's calling the sum? Main. It is giving values to the x and y as 2 and 3, and the return value is of course 5, and that return value is assigned to L, and that is printed. Now this is printed. Now I call another this function, that is large function. Now control is transferred to the large. It has got a conditional. Let me check what is within A and B. All debug. What is A? All debug. What is B? Now A has a value 3 and B has a value 4. Here when I call the function, the same order, I give the A value 2 and B as 3. Now once this value is here, since 2 is not greater than 3, so the condition was false. So if part is not executed, else but B is the largest. I get this message on the screen. My function has performed the job. The first B is largest. The first was first one is a message out of the addition. So I think it's clear now. Now I have got two modules. One module or one function is doing with the addition of two numbers. Another function is doing with the what you call comparison of the two numbers and telling me which number is largest, whether the first number, that is A, is largest or B is largest. Then I can write as many functions as within the program, and those functions can be called again and again. So function, as I tell you now, it's a independent block of code. Then I can show you another function that I have already given, that is the volume of cuboid. We can call this function as volume. It accepts three numbers, so I have got three arguments. I can take it for simplicity as integers, int A, int B, int C. Even though in real life they are not integers, I'll give return type, the type of values that will be computed will be integers. Once I multiply three integers, I'll get an integer only, because the calculation of volume is like that only. Then I write the body. Now I have to compute the value, so I declare a variable called result, and the type of result should match with the return type, that is int. Then I say my result is equal to what you call A into B into C. Okay, then I say return, because value is computed, return statement should be there, return result. Okay, then I call this function. This is my function definition. Where definition is equal to declarator, and I have given the body. Now let me call this function. Who will use it? Man will use it. It will call volume, and it will give three arguments, actual arguments, 1, 4, 2. So volume of cuboid will be 4 into 2, that's 8 units, whatever is the unit. Then it will give me the value here, that I will assign to some variable, say D, which I have to declare in the main. No, whatever variables I'll be using in the main, I have to declare them. Whatever variables I'll be using in the volume, I'll have to declare them. Whatever variables I'll be using in the large, I have to declare them. Whatever variables I'll be using in sum, I have to declare them. I am using a result here. In the large, I am not using a result, so I'm not declaring the third variable. But in the volume, I am getting the result. So here the return type should be void, because I'm not getting some computed value in case of large. But in volume, the return type should have some type, that is the return type of the result. And now I am assigning it to D. Its return type should match with this. Even though errors will come even if it's of different return type, but remember it should match at three places. First, the return type of the variable in which you are storing the answer. Second, the return type of the function. And third, the return type of the variable in which you are assigning the value. These three should match. Now let us see. What's the error here? Statement missing. Oh yes. At the end of the assignment statement, there should be a semicolon. This was the error. Now, first clear screen, then sum is called. Who is calling main? Then I get the result. I have already explained. The large is called. Then it will determine the largest of the two numbers. I can change the inputs for the next call. Then I'm calling volume. Then I'm storing the answer in the result. You can watch again, debug, watch, and watch the result. No, I'm not seeing it here. I need to see it. See, the result is having junk value because we are still here. Result has not been computed. After it is result is 8 because value of A was given as 1-to-1 matching 1, then B was 4 and C was 2. So then we are doing A into B into C, that is we are multiplying this A, this B and this C, and once it is being multiplied we generate the result, and the return value is given back to the main. Okay, and that is stored in D. We can watch the debug, watch and watch and D. The return value again, that is 8. Okay, I hope I have given you a quick brush up of what are the functions. To summarize, I say the functions are independent block of code. These block of codes can be again called again and again. Again, these functions have the inputs or they may not have inputs. If they have inputs, we have to see what are the inputs, and if they may have outputs or they may not have outputs. Even in case they don't have outputs, they are called void. The return type is void. In case they have the outputs, then we have to see the data type of the result, and we have to give that in the beginning of the function, that is in the first line. Then we give the name of the function, and we give its arguments, that is the actual arguments and their data types. Then we write the body of the function and we do the computation, and we write a return statement. Return statement is a special statement. Again, this is an unconditional statement, and that transfers the control from the functions. As I told you, there are certain unconditional statements. Previously I have given introduction to the two of them, that is the break and what was another, that was continue, that we used in the loops. Then we have the unconditional statement, that is unconditional what you call statement, that is the return, and we have another unconditional statement, that is go to. Okay, return and go to and break and continue are same in the sense that they don't have a condition. Okay, then we learned that why we use functions. We divided our program into different subtasks, and each subtask can be defined clearly, and we call each subtask as a module, and this is called as a modularization, and each subtask can be utilized again and again, that we call as a reusability of the code. In this way, debugging is also easy because we have divided our program into subtasks, and if there's a problem with a particular subtask or a function, that can be easily identified. And then again, I have told what are the different other concepts that are related to a function that I'll be taking in the subsequent classes. I hope you have enjoyed today's class, and we'll be having subsequent lectures on this concept again, so that it gets what you call inscribed in your mind and you understand it in a very nice way. No need to worry if you have understood incompletely. I'll be again giving the refinements of these topics, and it will be clear with time. Okay, thank you.